Hey everyone, in this video I'm going to go through using Ceedling to write tests. So we're going to test a function from the command system in OBC command. So we're going to be testing this function here, OBC command parse and invoke. And what I've done is I've already written these tests, but I want to go through pretty much as if I were starting from scratch, because the way I tend to write unit tests really involves starting at a super basic level, trying to run the test, fixing stuff until it works, and then once you have that there, then you can actually go add functionality to your tests and test more advanced things. And you'll probably find once you've got a unit test or two built and working, then it's pretty simple to add further unit tests for that function. So the function that we're going to be testing is this one, and when you're unit testing, the level of access that you have is essentially anything that's in the header file for a particular module. So this function is visible, and this internal command function is also visible, so we could go write tests for either of those. And ultimately what we end up doing is testing certain combinations of inputs, and we end up checking the outputs. And the other thing we can be doing is mocking functions that this function under test will be calling. And in our mocks, we can have it, for example, return a failure case or something like that. And with the way we have all the OBC error codes defined, it's fairly easy to write a mock that, for example, returns an error code, and then you can check that after this function under test runs, it kind of bubbles up the error code appropriately and probably gives us an error on its output here as well. So let's get started. The first thing you need to do is create a new C file to contain the test. And there's a naming convention here, so it has to start with test underscore, and then the name of the module you're testing. So it's going to be the same name as the header file that we have here. And that has to be placed under orcasat testing, under tests, and then there's your module. The code I have here on the screen is just the basic boilerplate. Every test is going to have this, so you need to include Unity, which is the assertion framework that we'll be using. Obviously a bit of documentation, and then the setup function, which we're not actually going to touch in this video. The next thing we need to do is declare a test function. So we'll do that here, and let's go add the implementation and document this as well. So I'm being a bit generic here just for the sake of speed, but anyway, this function is where we're going to be doing all of our testing. So the first thing I'll do is I'll just copy in the declaration for the function I actually want to be testing, just so it's kind of here for me and I can look at it and explain some stuff. And from here, like, this is the interface, so I have to think about what I want to do. So what this function does is it takes in a pointer to an array of characters which have been received over the serial port, and it ends up looking through that array of characters and deciding, picking the right command to actually run. It returns various error codes if bad things happen. For example, if we try to run a command that doesn't actually exist. And then right now, in a bit of a quirk of just where we are in development right now, this action ID argument isn't really used, and we'll just be setting it to null. So let's say the first thing I want to do usually is test the happy case. So usually I probably kind of know what's supposed to happen here. In this case, I have a command that I know should be executed properly. So let's test that actually can happen. So I'm going to build my command here. So it's just a character array, and we'll send the ACK command, and we'll do a whole valid command in like OBC command language here. So that's the command we actually are going to be sending in during this test. So let's replace that argument. And as I mentioned before, we're not actually using this action ID argument. So let's just set it to null and then not worry about it anymore. And the other thing we can do is we can actually add our first assertion. So this function returns an error code of some description. And since we know this is a valid command, we can actually just, I guess, go dig into the implementation. And we should see it's going to return immediate success if the command is valid and everything. So we'll just copy that. And here's where we get into Unity, which is how we make assertions that things are happening in a test. When I'm writing tests, I like to have this Unity assertions reference guide up. You can just Google Unity assertions reference and you'll get it. It's also linked in the wiki somewhere as well. So if you go down a bit, this shows you all the kinds of assertions you can make. One that you'll be using a lot is just integer assertions. So what we can do here is wrap that test function call in an assertion and expect that it's going to return this, what was it, OBC immediate command success value here. So the assertion looks like test assert equal int 32. So you have to know what kind of type you're dealing with, and expected or actual. So I think I have my, oh, that's the whole thing. I'll just go ahead and copy the actual enum here. And then we're calling our function that we're testing, and let's just close that out. So this really in itself is a super basic test. We're testing that when this command is sent to this function returns this immediate success value. Let's go see what happens when we try to run this. Usually you'll find, so this is about as simple as you can get. You'd probably kind of start here if you're testing something else. And then we'll work through the process of doing some other things, which will come up when I try to actually run it. So I've got Ceedling installed on my system. The instructions for that are in the wiki as well. And you can run all the tests just by typing Ceedling, but for this example, may as well just only run the test that we're writing new here. So Ceedling test colon and then the name of the module that you're testing, which is OBC command. So I'll hit that and let's see what happens. We've got a bunch of problems. This is pretty normal. And when you write a new test, this will almost always happen, and there's just kind of a process of figuring out what to include to actually get your test to compile. So got a decently helpful error message here. This OBC immediate command success value isn't declared anywhere. And so that value comes from OBC error. That's where we have all our error codes defined. So let's include OBC. And the other thing I forgot to do, you always want to, of course, include the header for the module that you're actually testing. So OBC command.h. Okay, so I've got that. Let's try to run the tests again and see what happens. Okay, still got some errors here. So I'm going to ignore the warnings for now and look at the errors instead. So this will happen a lot for you as well. Undefined symbols. That's basically what we had before with the error enum that we didn't have access to, but these are functions. Ignore the underscore. That's just, I guess, some name mangling somewhere going on. But some of these may be familiar to you. For example, log string, work time init. These are used in other places, and the reason we're getting this error is that we're not including these headers. However, depending on the header, or depending on what the symbol is that it can't find, you probably want to not include the real header. You want to include a mock header. For example, if let's say we included logger.h, which has the log string function in it. That would link the entire real logger module into this test, and that tries to do things like talk to the UART or read from the RTC, which are other things that the test doesn't actually know how to do. So that's where mocks start coming into play. And a mock is just a fake version of some function that you typically have some control over. We'll see how to use log string especially. But for now, what you need to know is if you see this kind of thing, chances are the way to solve it will be to include mock versions of the appropriate headers. And the mocks are generated automatically by CMOC, which is one of the is basically the reason we're using Ceedling, because it makes it really easy. So let's kind of home in on this log string method here. That comes from the logger module. So instead of including logger.h, we will include mocklogger.h. Okay, cool. So now when we run that test again, we should see that that particular thing has gone away. Okay, cool. So now we've just got some other things that we've got to include the mocks for, basically. Here's actually one exception. The C sequence to num. This function is normally in OBC utils. And OBC utils doesn't try to talk to hardware and doesn't really include any other complicated functionality. So in that case, it's fine to actually just include the proper OBC utils header. But this is honestly one of the only places you wouldn't actually include the mock version. Okay, so that's good. Let's see what else I've got. Orca time init. I know that that is included in OBC time. And Orca time init is it's just a constant value. So that's another case where it's okay to not include the mock. Although I think either would be okay. What about something like schedule action? So the scheduler module is pretty complicated. It calls a lot of things. And in this particular testing situation, we want to be able to control how that's working. So we need to include mock obc scheduler.h, or yeah, mock. So let's include that. I've got the canonical example of this test that I'm kind of copying off screen here, so I've already figured these things out. But if you're doing this from scratch, you're not going to have that. So the way you find these things is go into your real module under test and go search for the function without this leading underscore. And depending on what editor you're using or whatever, either go to definition or declaration, or I can command click on it and it'll open it up, and then now I know where it comes from. Might not always be obvious. So yeah, just use your IDE to figure out where things are. Scheduler, and so I've got a couple others that I'll just copy over. So this heartbeat thing, I think that's actually the only other mock that I need to include. And let's run that test again and see what happens. Cool. Okay, not bad. So our test is actually failing now. So we can see why it is failing. And what it's telling us is this function is called more times than we expected. So let's maybe walk through how that's occurring. So Ceedling is running this test, and this test is calling our real function. And our real function ends up calling scheduler or schedule action start now. And since we included the mock scheduler header, this function here is something that Ceedling knows about. It's looking to see when it gets called. And so it's seeing that, hey, we're calling this function and we didn't expect to, because we haven't told it what we expect to happen, other than that we want to return this success code here. So here's where we get into mocking things. So maybe I will, well, let's start off with the reference material. So the mocking system is called Unity, is called CMOC. And kind of like the assertion reference, the CMOC summary is a pretty good document to take a look through the first couple times you're writing tests, and I often have it open when I'm doing this. And the way mocks work is essentially we tell Ceedling or CMOC when we expect something to happen, and we can tell it some of the details about what we expect to happen. For example, we expect that our function under test is going to call scheduler schedule action start now, and it's going to give it certain values for its arguments. That's something we can tell Ceedling about, and that's what we're going to do now. The other important thing is you're also able to ignore arguments, which we'll get at in a second here. So I'm just going to, let's add actually I'll copy in some code, and I'll just kind of explain it. It's faster than typing. So what we're doing in our test is, before we're calling our function under test here, we're setting up what we expect to have happen in terms of the mock stuff. So we expect it to call this function, and what CMOC does is it gives us some definitions with things tacked on the end, like expect and return. What expect and return does is it lets us give it values of the arguments, and it lets us tell Ceedling what value this particular fake version of this function is going to return. Let's maybe take a look at what this function normally looks like in the real version. So in the real version, it takes an ID, takes a couple of values, and a couple of them are references, and yeah. And you have to kind of know the specifics of what you're testing. But in this case, I don't really care what this ID is, but I do know what the submission source is. I do know what the interval is, because the function under test is pulling that value out. The action we don't really care about. That's sort of another detail that's not particularly important. But the argument size is also something that I want to check is correct. And the argument data also, that's another one that doesn't matter. So what I've done is I have put the expected values for the arguments that I care about. So I mentioned I care about the source, that it's external. I care that, what's the third one? I care that the interval in this case is 0, but I'm going to change that to 5, and I'll change my command as well just to make it a bit more interesting. And then we had an argument I don't care about. Then I had this was the number of parameters that this command has, which is 0. Let's actually add a parameter, and then we can test that that's correct. So I'll just add some other thing. And the parameter, the number I expect here, I'll just go to my reference, is going to be this value here. And this is totally an implementation detail of my function. So I'd be looking at the source code, figuring out what these things should be as I'm doing this. Then one we don't care about. And then this last value here is what we want this mocked version to return. So we're testing happy path right now. So that this function, let's say, is going to return scheduler success. And if I check out the documentation for this function, that's the happy path. So let's do that. So what have I done? I've created the fake command I want to put into my function under test. I've told Ceedling a bit about what I expect to have happen. Then I call my function under test, and I expect that it's going to be returning this value. And I've mocked one of the calls that I know this function is going to make. But in this case, there are a bunch of arguments here that I don't care about. And CMOC has a feature that allows me to ignore those arguments. So I've set them to null, but that doesn't get me all the way there. Ceedling would give probably a bunch of errors about that. So that's where you use these ignore argument sort of definitions. They're macros, but yeah. So for all the arguments that I am going to not care about in this test, I'm going to make these calls here. And the last bit of this call is the name of the argument that I don't care about. So the ID is the first one. I've set it to null, and I've said ID, so I don't care about that one. And I've got a couple others that I'll just paste in here as well. So that now I've set up the full details about what I expect to have happen with this particular function. One thing that can be a bit difficult sometimes is getting the specifics of these mocks right. So like there are a lot of options and they chain themselves together in certain ways, and it's not always obvious if I want to ignore this argument, what is the mocked version of the function actually called. To find out, assuming you've run Ceedling once and it's generated all this stuff, we can actually go into the mock header that Ceedling, or I guess CMock, generates. So let's just close all those folders. Then it's called orgset testing, and then build, and then test, and then mocks. And there you see we've got header files and C files for all of the mocks that we told it at the top of the test we want to include. So it's generated these automatically, and there's a lot here, and it can be a little tricky to read sometimes, but these are all the options you have for calling or for mocking this particular call. So let's say I knew it was calling schedule action start now. I could copy that and search for it in here, and then here are all the options. So I can ignore and return, which just totally skips it. I can expect and return, which lets me set up which values I expect are going to be passed into it. Then I can do all these other things. I can ignore these other arguments, all that kind of thing. So this is your real reference for your mocks, is the actual generated header that you can get to in orgset testing, build, test, mocks. Anyway, let's go back to the actual test. Make sure that's saved, and let's run it again. See what happens. And okay, we've got another situation where we have a function that we don't have a mock for yet. So it's calling log string, which makes sense because when we send a command to the OBC, it always sends out a response message using log string. So I'm just going to pull in my mock that I created earlier, and it should make a lot of sense. So in this case, so we have log string, which is the function, and then the expect suffix here, which is from CMock. And I know that this is what I expect to happen. It's an info message. It's a command general ID, not saved to file, and then this is the text that I expect my function under test is going to be feeding to log string. And we can actually see that if we go into the implementation, OBC command, and it was find command, it was parse. It's a function under test parse and invoke. Just find that. So here's the call that we're actually we're checking is correct here. And so that matches, or this is rather what I expect to happen. Cool. Let's run this test. Nice. So it actually passed this time. That indicates that number one, all of the things that were mocked have been mocked. I've included all of the correct headers that have the pre-generated mocks in them, and I have set up my expectations correctly. Let's maybe poke around and change some of the expectations and see the test fail. For example, what if, for whatever reason, I expect that when my function under test, which is this last one here, is going to call a log string and it's going to have an error message in it. So let's set up that expectation and then run my test, and it failed. So it can sometimes be a little confusing. Expected 2, but was 1. Yeah, it just doesn't know. It can't sort out the enums, so it's just giving me the raw values. But if I were to go dig into the header and find the definition, I would find that error is 1, and what was it, info that I had before, there's the correct value maps to 2. Anyway, so that's sort of one thing. What else can I do? I can change other expectations, or actually I can... What if I didn't care about any of the arguments that are getting passed to schedule, start, action, start now? There's another option for mocking it. I can do, what is it? Scheduler, action, start now. I can do ignore and return. Which will just ignore all of the arguments and not check them. So if I didn't really care what the arguments passed in by my function were, then I could do this. So I'll just I'll make sure that those are commented out. And I'll run that, and that passed as well. I could do something like, well, this is a mock, so what if I wanted to test what happens when my function under test here gets a failure, an error code from the scheduler when it tries to schedule the action? I could do, what is it? Find success. Let's find an error code here that I can use. What if it gives me this error code? So this is my fake version of this function. I'm telling CMock or Ceedling that I want it to return this value, and my function under test is going to get that value, and I want to see number 1, what it does with it, and number 2, check that that's actually correct. So I think what should happen here is if the scheduler gives an error code to my function should end up printing an error message of some sort. So I think we should see that when we run the test. Expected 1, so, and was 2, so error. And if I run that again, let's see what happens. Okay, this makes sense. So Ceedling saying we expected it to make a log string call with this text in it, but what we got was a log string call with shed error here, and I can actually go find that in the real implementation. So things kind of map up. So I could change this here, or I could just go back. Let's maybe go back to what we had before. Sort of the fully featured with expectation and ignoring and that kind of thing. But that case where the scheduler mock, I think it deleted something. Oh, maybe not. That case where the scheduler mock returned an error code, and I wanted to check what my function under test did with it, and I presumably know what that should be, and and I want to test that it's correct, that's a perfect candidate for another test. So maybe I'd call that test command schedule error or something like that. And what I would do is I would copy everything I have here, change the mock around a little bit to, for example, return that error code, and then I change my expectations around a little bit to I expect that we're going to get an error message, and then there we go. That's another test of a pretty important case. What happens when the scheduler says, I can't do this? How does my function under test react to that? So that it gets into, once you have a test or two implemented and you kind of you mock enough stuff to get most of the way there, it becomes quite quick to add other tests to your test suite, because once you got kind of your base level of functionality, it really just involves tweaking an expectation here and there, tweaking an input a little bit to get a different behavior to come out or something like that. So it becomes a lot easier to write new tests once you've got a couple of tests that work. Anyway, I hope this was useful to kind of show you the process of how do we start from a module that you want to test to actually writing a test and working through sort of the whole cycle of failures and getting the right things mocked and that sort of thing. And also how to kind of, once you have a single test, how do you tweak it so that you can go build new tests that also do things that are useful. And I hope I also gave enough kind of tricks like looking at the actual mock header that CMOC generates, so you can figure out what are all the options here for my mocks. How can I actually build these? What are the tools that are generated for me to actually do that? Yeah, anyway, thanks for watching. And I guess the only other thing I will say about writing tests is it's a really good idea to look at the other tests that are in or that are created already. You'll see some other features used in some, for example, RTC, yeah, here's one. Instead of writing a whole pile of individual tests to test like all these different essentially command arguments, I think is what this is doing. Building an array of them into your test and then having your test just loop through that array and expecting stuff. This can be a useful technique when you want to hit a bunch of values, or if you're able to generate some stimulus programmatically. That's also a really useful thing to do to kind of get better coverage, as opposed to the test that we wrote in the video where we're testing like literally one example. There could totally be bugs hiding elsewhere, like what happens if we have too many arguments, or what happens if an argument is really long, or something like that. It can also be good to think about usually after you've got some baseline tests that are kind of simple, kind of contrived, or really manually built. Think about how you can generate test stimulus and get more cases and things like that.